Hi everyone, I'm P. Ramesh, Assistant Professor, Department of Mathematics of Dr. SNS Rajeshwari College of Arts and Science. In this lecture series video, we are going to discuss about the application of queuing theory to the bank ATM. Already in the previous video, lecture series, we discussed what is the introduction of queuing system, what is a what's the different formula to calculate length of the system, length of the queue, waiting time in the system, waiting time in the queue, and characterization of queuing system. Everything we already discussed. So continuously in this lecture series video, we have discussed this application of queuing theory to the bank ATM. So consider queuing theory to study the waiting line in ABC Bank ATM at Kandipuram, Coimbatore. The bank provides one ATM in every branch in ATM. Bank customers arrive randomly and the service time is also random. We use Little's theorem and the MM1 queuing model to derive the arrival rate, service rate, utilization rate, waiting time in the queue. Okay, now we have on average 600 customers are served on weekdays. Weekdays means here we take Sunday to Thursday, and 300 customers are served on weekends. Weekends are denoted by the Friday and Saturday monthly. So we consider this slab. So generally on Sunday, there are more customers coming to ATM during 10 a.m. to 6 p.m. Okay. So the arrival rate of the bank ATM on Sunday during bank time is one customer per minute. So we call it as it is CPM. C for customer, P for per, M for minute. So CPM means customer per minute. While the service rate is 1.5 CPM. The average number of customers in this ATM is 2 and the utilization period, that is rho, is 0.70. We discuss the benefit of performing queuing analysis to a busy ATM. Okay. So already we discussed, we apply some of the formula here. In this MM1 model, we follow the formula lambda. Lambda means the mean arrival rate of the customer, and the mu is the service rate. Utilization factor or system is free is denoted by rho, that is lambda by mu. Suppose none of the customer in the ATM, so it is rho power, it is P0. Probability for none of customer in the ATM is P0, that is 1 minus rho. Suppose n customer in the ATM, we calculated what is the probability for n customer in the ATM is P of n. Probability for n customer in the system is rho power n into 1 minus rho. If n is equal to 0 means no customer in the ATM. Therefore, rho power 0 to 1 minus rho. So we get to 1 minus rho, that is P0, right? The average number of customers in the ATM, that is the length of the system, is rho by 1 minus rho. And the average number of customers in the queue is just multiple rho in the numerator. So we get rho square by 1 minus rho. And the average waiting time in the queue is 1 by mu minus lambda. Average waiting time in ATM, including the waiting time, is rho divided by mu minus lambda. So we calculate all these things. Okay, now observed and discussions. We collected 1 month report here. The day week, first week, Sunday 70, so Saturday 70, Sunday 191, Monday 161, Tuesday 120, Wednesday 130, Thursday 111, Friday 95, and second week, like a second week 75, Sunday 154, and so on up to 4 weeks. Okay, so total number of there are in this 4 weeks, the total for Saturday is 260 peoples, Sunday 600 peoples, on Monday 549 peoples, and Tuesday 443 peoples, Wednesday 408 peoples, and Thursday 394. Mostly Friday is 370 peoples to visit the ATM. From the table, observe that the number of customers on Sunday is double the number of customers on Saturday during a month. The busiest period for the bank ATM is Sunday and Monday during bank time. Bank time is 10 a.m. to 6 p.m. Hence, the time period is very important for the research. Also, we observed from the figure, so from the table, after Sunday, the number of customers start decreasing slowly at the end of the progression. On Saturday, it is least, and Thursday and Friday, it says slightly more than the Saturdays. So this is because the Friday and Saturday will be a holiday. Okay, we consider these things. So correct. Now we calculate this. We investigate that after Saturday, during the first 2 days of the week, there are on average 60 people coming to the ATM on our time period for bank time. From this, we can derive the arrival rate as 60 divided by 60, that is equal to one customer per minute. We also found out from observations, discussions with got that each customer spend 2 minutes on the average in ATM. The customer length around three peoples on the average, and the average waiting time around 2.5 minutes, therefore 150 seconds the waiting. So now we calculate the average number of peoples in ATM, 1 CPM into 2 minutes, therefore 2 customer. So what is utilization factor? It is rho, that is lambda by mu. The ATM is always busy. That means the peoples continuously enter the ATM and get the service. So that is utilization factor. We calculate that one is by rho. So rho is lambda by mu. Already we have lambda is 1 CBM and mu is previously calculated, it is 1.5 CBM. So totally zero point 0.7. With a very high utilization rate of zero point 0.7 during bank time, the probability of zero customer in the ATM is very small, can be derived. P0, that is 1 minus rho, is zero point 0.3. So the queuing theory provides a formula to calculate the probability of having a customer in the ATM means uh, probability of n customer is rho power n 1 minus rho, that is 0.30 into zero point 0.7 whole power n. So from that, we calculate the number of customers arrived. So consequently, we calculate what is the probability value. So here we also assume that the maximum queue length that the passion customers can tolerate in 10 peoples, as a capacity of ATM is 1 people, we can calculate the probability 4 people in the system, that is in the ATM. Evaluation to utilization is directly proportional to the mean number of customers. It means that the mean number of customers will increase in the utilization increase. The utilization rate of ATM is very high at 0.70. This, however, is only the utilization rate during the bank time on Sundays and Mondays. On weekend, the utilization rate is almost half of it. This is because the number of customers on weekends is only on the number of people on weekdays. So in case of customers, waiting time is lower, or in other words, we waited for less than 150 seconds, the number of customers that are able to serve for a minute will increase. When the service rate is higher, the utilization will be lower, which makes the probability of the customers going away decreases. So using all this, what's the conclusions? From the result, we have obtained that the rate at which customer arrive in the queuing system, one customer per minute, and the service rate is 1.5 customers per minute. The probability of a buffer flow, if there are three or more customers in the queue, is 10 out of 100 customers. The probability of buffer overflow in the probability that customers will run away because maybe they are impatient to wait in the queue. Thank you.